All right, guys, this is going to be section number 2. That's going to be classifying real numbers. So this is that one diagram that we had with the natural whole integers and got bigger, the one that kind of looked like this. I would put that on my note card if possible. But we're going to go ahead and start here. So a couple things to remember with your natural numbers, that your natural numbers are going to be positive numbers. And those are your counting numbers, 1, 2, 3, 4, 5. And then your whole numbers are going to be your positive numbers with 0. So these are 0, 1, 2, 3, 4, 5. Your integers, these are going to be your positive and negative whole numbers. And that's really, really, really important. Whole numbers. That is your important word right there. And then your rational numbers are your fractions, your decimals, and anything, like if I check it here, I can check it there. So we'll get to that. So the first one is -5. Now, if your number is not positive, it can't go in either one of these two. If it's a negative whole number, it jumps straight to the integers, and we'll put a check there. Don't check it if it's not there. Now, if it's an integer, it can also be a rational number because I can make that into a fraction. So it's also a rational number. Now, 1/3. When we think about 1/3, it's not a whole number. So if it's not whole, then it can't be in either one of these two, and it's going to jump over here. But then this also has to be whole, so it can't even be there. It's just going to be a rational number because it's a fraction. So there's your key word, remember, whole. Now, if we look at this one, 10 divided by 2, that's an improper fraction. So if I actually solved 10 divided by 2, it would give me 5. Now, 5 is a whole number. Okay, it's also considered your natural number because it's one of those counting numbers. So it's a positive whole number. Here, positive whole number. And I can make it a fraction, and it was a fraction to begin with, so we know it goes there also. So if you can solve the problem and get a whole number, then it can belong in these categories. Now, the absolute value of 7 is 7. But the negative's on the outside, so that negative sticks with it, and it's a -7. Remember, these first two categories can only be positive numbers, so it can't go there. This is a negative whole number. Negative whole, that works. That's a yes. And we can make that a fraction by putting a 1 underneath it, so it's also a rational number. So you got to make sure you know those definitions. Okay, number 5 says the table shows the height of 4 students. Which student's height is a whole number? So what we're going to do for this problem is some work. So Jasmine is 49 divided by 5. We want that to be a whole number, not a decimal, not a fraction. So we're going to take 49 divided by 5. Well, 5 can go into 49 9 times. If I have anything left over, which I do, that's going to cause me to add a decimal and a 0, which means if I keep going, I have a decimal. That's not a whole number. So no, she is not a whole number. Jamie does not work for us. Now we're on Rose. Rose is 36 divided by 8. Well, 8 can go into 36 4 times. And I'm going to have left over, which causes me to add a decimal and a 0, which means that is not a whole number. So no, Rose is not a whole number. So now we're on to Mark. Mark is 144 divided by 12. Well, 12 can go into there 1 time. 2 left over, bring down the 4. 12 can go into 24 2 times, and that actually ends, and that is a whole number. So yes, Mark is the whole number. So who's the student? Mark. And my reasoning is because he's a whole number. The other names had decimals. So reasoning, this is reasoning too. I'm proving that those didn't work. You can also prove that the last one doesn't work if you want to show all of your work. So here, if we took this, let's try 7 and see what happens. 84 too high, so it's 12 times 6. 672. And that's going to give me 3 left over, which is going to cause me to bring that decimal down. So we'll have a decimal there too. All right. Place the numbers in the correct location on the diagram. So what you want to remember is, again, these definitions, and where would that number hit first? So here's a decimal. Remember your whole numbers? These are your positive numbers, okay? Your integers are your positive and negative whole numbers. And your rational numbers are your fractions, your decimals, and so on. So 5.2, these both have to be whole, so that does not work there. So 5.2 is going to go right here, 5.2. -8, well, these are only positive, so it can't go there. So -8 is a negative whole number, so -8 is going to go right there. 7, that's a whole positive number, so it's going to start right there. Where is it starting? Now 3 divided by 2, let's see what that is. It's a fraction, but if we actually solve it, what would it give us? So 1 left over, here's a decimal. So I already hit the decimal mark. So I know it's not a whole, that's your key word. So it's going to go here at the top, which is 3 divided by 2. It's a rational number. Okay, next problem, number 7. Name a number that would not be classified as a whole number and recorded on the grid. Okay, so think about it. If it's not a whole number, it can be a fraction or a decimal. So you can kind of pick any decimal. 7/10, 92 hundredths, 5/10. Doesn't matter what you pick. I'm going to pick one of these two. I'm going to do, let's see, 0.8. Any one of these are going to work. So I'm just going to put 7/10 since it was the first one. 7/10, and there we go. So think about what they're asking. If it's not a whole number, it's either a decimal or a fraction. Determine whether the following statement is true or false and defend your answer. So some rational numbers are whole numbers. Well, that's going to be true. Some rational numbers are whole numbers. So when we look here, if I have a rational number, remember a rational number is, it's a ratio, a comparison of two things, and if I simplify it, then it could also be a whole number. So for example, 8 divided by 2, that's rational because it's in a fraction form, but 8 divided by 2 is really 4. Okay, 4 divided by 1, that becomes a whole number also. Now, not all rational numbers, there's your keyword some, not all rational numbers are whole numbers. If you have a decimal, so let's say 5/10, this is not whole. So that is an example of not being whole. If you have 1/4, this is not whole. So not all whole numbers can go in rational, but some rational can be whole. All right, that is section 2. Make sure if you have any questions that you ask your teacher before your test. Good luck.